We discussed a resultant of the two vectors in previous lecture when two vectors are at some angle. So what is the resultant of those two vectors? We found that the resultant is given by, that's under root of a square plus b square plus 2ab cos theta. So this is the resultant, magnitude of the resultant when two vectors a and b are at some angle theta. Now suppose we assume that theta will see some special cases. If theta is equal to 0 degree, it means that we are given two vectors but they are along the same direction. Two vectors along same direction. So what will be the resultant of these two vectors? So I can write that r will be equal to, it will be under root of a square plus b square plus 2ab cos 0. Since we know that cos 0 degree is equal to 1, so our resultant will be equal to under root of a square plus b square plus 2ab. And I can write r is equal, since this will be a formula, a plus b whole square. So our resultant will be equal to a plus b. So we got that whenever we are having two vectors and they are having same direction, their theta will be 0 degree and their resultant will be equal to sum of the magnitudes of those two vectors. So I can see here that whenever two vectors are along the same direction, they behave like scalars, means we can add them like we add two scalars. So same condition will be here. Now another case is if we are having theta that is equal to 180 degree. It means we are having two vectors but they are anti-parallel to each other. So what will be the resultant of those two vectors? The resultant will be given by r is equal to under root of a square plus b square plus 2ab cos of 180 degree. Since we know that cos of 180 degree that is equal to -1, so we can write here that r will be under root of a square plus b square minus 2ab. So r will be under root of a minus b whole square. So the resultant will be equal to a minus b. So whenever we are having two vectors, they are anti-parallel to each other. So we have to, for finding the resultant, we can just subtract those two vectors. So again, when two vectors are anti-parallel, they again behave like scalars. Means we can again find the magnitude simply by subtracting those two vectors. So vectors behave like scalars when they are parallel or anti-parallel to each other. Okay.